Hi and welcome to this Rosvita tutorial. In this tutorial I'll show how to create a multi-waypoint trajectory and execute it with a xamla graph system. For this I've created a configuration which contains the Mecha 500. I've also started ROS, which is already on go. I'll now start a new XGraph workflow editor. To do this I click on New and XGraph workflow. A new XGraph workflow canvas opens. I'll now split the screen horizontally to see the robot in the upper part of the screen and the graph in the lower part. I'll now teach some poses for this operation. First of all, I'll create a new folder and I'll code this in the world view. I code this folder trajectory 1. Now I place the 3D cursor somewhere in the scene by clicking and ask the inverse kinematic to give me a pose for the robot for this position. I can now move the robot around and store values of the ghost for those positions. Here I'll now select random positions just to give an impression of it. And of course, you can also something out of the plane. Okay, and now I'll create the graph for this trajectory to execute. I want to execute a trajectory which goes to this joint positions, but it's not stopping on each of the joints values. So first of all, I'll start with a safe motion to the first point of the trajectory. For this, I'll create a supervised MoveJoints operation. Connect it with the begin flow and select the first point as the target for this operation. Then I'll insert a for loop in order to execute the trajectory over these 6 points in a loop. To get these values from the trajectory 1 folder, I use a module called QueryJointValuesByPrefix. I can specify the folder name here in the property sheets. Then I'll use a MoveJointsWaypoints operation, connect it to the flow end of the for loop and connect the waypoints. Then I'll connect it to the end of the graph. Now I hit start. What I'll see first is the supervised motion dialog, which asks me to confirm manually the motion of the robot. I can do this by holding down the forward button. As I release the button, the robot stops. I can also go backward to see the trajectory. If I keep holding, the robot will move to the final destination position, and then the remaining graph will start, which here consists mainly of the MoveJWaypoints operation, as the QueryJointValuesByPrefix is immediately completed. You see by the green borders which module is active. So in this case, most of the time here, the MoveJWaypoints operation is active. In order to make this a little bit more interesting, I'll stop now the graph and show a feature of the graph engine, which allows us to provide values to the modules not only by the property sheet, but also by a computation in the graph. To do this, I can click here right and select the velocityScaling field and remove it from the property container. Now I get a pin here on the MoveJWaypoints module. To provide a value for it, I'll insert a slider, but I could of course insert any module which generates a float 64 value. I select the slider, set it to some value, and now again execute the graph. Move again to the start position, and if the robot has reached there, the graph starts. Now for the first run, it starts with 75%. I can now reduce the speed here to 14%, and we'll see the next time the graph is the inner for loop cycle is evaluated, it will now reduce the speed of the robot to 14%. So you see, even while the whole system is running, you can still modify some values inside the graph system. For example, I could here set up a max deviation parameter, which is much higher, which would enable larger cornering and not reach so exactly into the individual points. Okay, that was what I wanted to show in this tutorial. Thank you very much for watching. If you have any questions, please go to discuss.xamla.com, and there you can directly get in touch with the development team of XAMLA. See you next time. Bye.